Just let maybe 1 minute more, let a couple more people join. Okay, hi folks. My name is John O'Reilly. I'm based in Galway in the west of Ireland. I would normally also say at this point that I live on the western edge of Europe, but it turns out that Lisbon is just a little bit further west than Galway, as it turns out. I'm a Kotlin GD. I work remotely as a staff engineer for a company called Crankin Technology. They're based in London and are part of the Octopus Energy Group. The plan today is that we're going to go on a guided tour of various libraries used in a number of the Kotlin multi-platform samples I've been working on, along with other folks over the last 5 years or so. Just to start with the usual show of hands, how many people here are using Kotlin multi-platform? Okay, quite a few. And how about Compose multi-platform? Okay, as expected, maybe a little bit less. I've been asking this question, by the way, in talks over the last 5 years. It's been fantastic to see the steady increase in people using it. Just to start with a tiny bit of background, I started taking an interest in Kotlin multi-platform around the end of 2018. And I had at this point here just about got something very basic up and running using this Galway bus app project. This had just been an Android-only app at the time and was in general a project I was using to try out new technology. Interestingly enough, the following day, June the 3rd, 2019, SwiftUI was announced at WWDC and was available to try out straight away, which of course I did. Jetpack Compose had been announced at Google I/O a few weeks before that. And so began this amazing combination of declarative UI and Kotlin multi-platform. And 5 years later, this is where I find myself with 11 KMP samples now, a number of them created in collaboration with other folks. So these samples cover use of a range of different architectures, remote access, persistence approaches, etc., and different libraries used for each of those in many cases. I'm not going through all of them, but we'll use a number of the samples to illustrate various patterns and some examples of how these libraries are used. By the way, I'm including links in various places so that hopefully these slides can act as somewhat of a reference for folks that want to look into them in detail at a later point. I'm going to use these specific 5 samples as a basis for our exploration today, illustrating use of the KMP and CMP libraries shown. These cover approaches for retrieving data from a backend, persisting locally, dependency injection, view model component sharing, navigation, Swift Kotlin interop, packaging, and also include a number of Compose multi-platform UI libraries as well. There's quite a few libraries here, so we won't go into great detail on each one, but we'll hopefully provide at least a flavor of what the library does and how it can be used. Before we get into details, I just want to give a big shout out to all the folks who have contributed to these samples over the years. In a number of cases, this was their first contribution to open source. By the way, these are the full set of libraries used in the samples I have. We have a number of the standard JetBrains libraries, a couple of libraries from Google that now support KMP, and then various third-party ones. Important to mention, of course, that there's a ton of other libraries available now as well. And speaking of which, just to highlight how many more KMP libraries there are these days. When I started looking into KMP, as I mentioned, in late 2018, I think there was maybe a handful available at the time. And not only do we have third-party libraries, but likes of Google now porting many of their libraries to work with KMP as well, which is great to see. So the first of the 5 samples we're going to cover is people in space. This was the first dedicated Kotlin multi-platform sample I created. The functionality in it is quite minimal, shows the list of people in space and the position of the International Space Station. We have Android, Wear OS, and iOS clients, along with Compose for Desktop and WASM-based Compose for Web clients as shown here, and also a Ktor-based backend in the project. And this is a high-level architecture diagram showing the key moving parts of the project. We're using Jetpack view model in shared code, more about that later in the talk, using Ktor to make HTTP requests to the backend, and SQLite then to store the data retrieved in a local database. And that database is used then to what's used to drive the UI. We also have some Compose UI shared code across the platforms. And this section we're going to talk about Coin, Ktor, SQLite, and KMP native coroutines. First library we're going to talk about is Coin. It's the dependency injection framework I use in most of the KMP samples I have. I think it's also probably fair to say that it's currently the most popular DI library used in KMP projects. With Coin, we define our dependencies in a series of modules, module definitions like this. In a KMP project, we typically have one module for common dependencies, as shown here, And then use KMP's expect actual for a module that we define for each platform, as we'll see shortly. And also showing here an example of injecting dependencies using coin, in this case injecting the dependencies into the repository class. And these are the platform modules for iOS and Android, for example, using for the SQLite database driver and the Ktor HTTP client engine, which need to be defined separately for each platform. And as we'll see shortly, these platform-specific versions of these dependencies will get injected automatically into common code that depends on them. Next up, we're using Ktor for making remote HTTP requests to the backend. Ktor includes libraries for both the client and server, but we'll be focusing on the client here. But there are, by the way, Ktor-based backends in a number of the samples if folks are interested in taking a look. And this is some of the initial plumbing we create to allow using Ktor. We're using Kotlin X serialization library, so we just need to configure that so it can be used, for example, for deserializing the JSON we get back to Kotlin data classes. That JSON instance is automatically passed into the create HTTP client method shown here, along with the client engine we showed earlier. Note again, this is common code, but then appropriate platform-specific version of that engine will get injected. Here we see again the Android and iOS-specific versions of the Ktor engine being created in Coin platform-specific modules. Okay, so showing here the data classes for the list of people and also for the position of the International Space Station. The JSON returned from the backend will automatically be deserialized into these classes by the Kotlin X serialization library as mentioned. And then two methods, fetch people and fetch ISS position for the API class that use Ktor to make requests to the backend. And again, we're using Coin here to inject the HTTP client object into the people in space API class. Okay, now that we've got our data from the backend, we need to store it locally on the device. And for that, we use the SQLite library. This works by generating type-safe Kotlin code from a series of SQL statements. And these are the SQL statements for the people in space sample. We have a statement for creating the table, and one for inserting, selecting, and deleting data. And note that the names shown above the statements are what are using Kotlin code generated, as we'll see next. We can now use the generated code to store the data we retrieve from our backend into a local database. We create a transaction here, and within that, in this example, we delete existing data and store the new ones. And note again that delete all and insert item were generated based on what we defined in our SQL file. And here we use the generated select all to retrieve the data from the backend and expose as a Kotlin flow, which we'll use to drive our UI. We also use this mapper here to convert the result of the query into a Kotlin data class. And just a very small example from the project of a SQLite database migration as well. As an aside, the endpoint I used to get the data doesn't include this info. So I ended up creating a Ktor backend that proxies the request and augments the result with additional data. So I've had to add these to the database as well. That backend, by the way, is in the repo if folks are interested in taking a look at some point. One other library I want to highlight for this sample is KMP native coroutines. And it's one I use in a number of the other samples as well. It supports mapping Kotlin coroutines to a range of different Swift concurrency frameworks. But these days I'm using it primarily for mapping to new structured concurrency capabilities that were introduced in Swift 5.5. Showing an example here from People in Space, where we have a Kotlin method in shared code that returns a flow representing the position of the International Space Station. And then in Swift, we use for-await to observe the data. For-await being effectively equivalent to collect in Kotlin. And note that if this is cancelled in Swift, then that cancellation gets propagated to the Kotlin flow as well. We can also use KMP native coroutines to seamlessly invoke Kotlin suspend functions using Swift's await. The next example we're using is Confetti. This is a Kotlin multi-platform project for showing information for a range of conferences. For example, DroidconLisbon. It includes various clients, along with the GraphQL backend, thanks to Martin Bonin. Here we have the iOS, Android, and also a Wear OS 1, which was created by Yuri Shimka, who, by the way, also contributed Wear OS clients to a number of the other samples as well. It has a Compose for Desktop client, and also a WASM-based Compose for Web 1 as well, as shown here. And even has Android automated support thanks to Carlos Mota. And again, showing the high-level architecture. Key thing here is the use of decomposed components and using Apollo to interact with the GraphQL backend. We'll talk about both shortly. We're also sharing some of the composed code across the clients in this project. By the way, just another quick show of hands. Anyone here using decompose? Okay, one, I think two maybe. How many people using GraphQL? Okay, not several. And I think it's probably, at least in the Kotlin world, Apollo is probably the standard approach that people are using for interacting with GraphQL backends. And showing example of this section of, as mentioned, Apollo Kotlin, decompose, multi-platform settings, and coil. As mentioned, the clients in this project interact with the GraphQL backend, and for that we're using the Apollo Kotlin library. It's described as a strongly typed caching client that automatically generates APIs from our GraphQL queries and backend schema. The caching aspect of this is very important as well, giving us effectively an all-in-one solution for both retrieving the data from the backend and storing it locally. To use it, we need to initially create this Apollo client object to make various requests. So this is an example of how this can be done. We provide, in this case, a URL, a header containing the conference name, and details of both the in-memory and persistence cache we'll be using. And showing a few examples of its usage. Firstly, for retrieving the list of conferences. Shown here is the GraphQL query that this is based on, and then use of the Kotlin code that Apollo generated to execute the query. The conference data class reference here is also generated by Apollo based on what we specified in the query. And then this is what's known as a GraphQL mutation, where we update data in the backend, in this case adding a bookmark for a session. And again, we make use of the Apollo generated code to perform that mutation. Next up is decompose. This is a library based on the idea of breaking our code into a tree of lifecycle aware components that contain observable state, have routing navigation functionality, and into which we can plug our UI. These are most of the decomposed components used in the Confetti project. We see, for example, ones for the list of conferences, session info for a particular conference, speakers, bookmarks, venue info, etc. And if we focus in, for example, on these particular components, these are the set of components associated with the screens we can navigate to from the home screen shown here, corresponding to tabs shown at the bottom, sessions, speakers, bookmarks, and venue. And the key thing here is that the components themselves know nothing about the UI. We just hook up particular UI screens to the appropriate component. We start by showing the set of children defined for home component. We'll explore a little in the next few slides, example of how we'd navigate to the speaker's child and associated UI. So if we drill into a somewhat condensed version of home component, this is the decomposed component, which, as we mentioned, is associated with the home screen in our app. First important concept here is the child stack. It's described as a navigation model for managing a stack of components. The UI, as we see shortly, will observe the current active child in the stack and use that to decide what to show. The child stack is also passed a factory that's used to create child components, which we'll show next. This is the child factory mentioned, and it's used, as the name suggests, to create particular children given a configuration passed to it. For example, config.speakers maps to child.speakers, which in turn wraps an instance of speakers component. We also see an example of how we'd navigate to that child in this on-speaker tab click method that's invoked from the UI. That navigation.bring to front is past the config.speakers configuration, which, as we saw, will map to child.speakers, which then becomes the active child. And this is how, in this example, we decide when to show that speaker's UI. In this case, firstly, in the compose client. We observe the active child instance from the component stack we saw earlier, see that it's set to child.speakers, as we saw in the previous slide, and then navigate to that screen, passing in, importantly, the associated child component as well. An almost identical code in the iOS SwiftUI client, for example, again observing the component stack to decide which view to show. Next up is multi-platform settings library, designed to allow persisting key value data in KMP projects. So this is an excerpt from the Confetti project, where we're storing the name of the conference the user selected. If that value is set, then we bypass the conference list screen next time the app is launched. And we're also observing that setting as a Kotlin flow. The flow setting type of the settings parameter is an abstraction from the multi-platform settings library. And again, we use platform-specific code then to create the appropriate implementation of that. These are part of the COIN platform module definitions for Android and iOS, for example, using data store settings as the implementation on Android, and NS user default settings on iOS. The last library I'm going to show for this sample is Coil, one that folks might be familiar with from Android. It provides image loading, rendering functionality, and now also supports Compose multi-platform. And this is a small example of it being used to show profile images in the session detail screen in Confetti. In this case, in shared Compose multi-platform code that's also been consumed in the iOS client as shown here. Next KMP sample is bike share. This shows the list of bike share networks for particular countries and bike availability info for each network. Again, we have Android and iOS clients. We also have a Compose for desktop client, and as shown here, a WASM-based Compose for Web 1 as well. In this case, we're using the KMP Observable View Model library for our shared view models, using Ktor to retrieve the data from the backend, and then persisting it locally using the Realm Kotlin library. And we've been talking in this section about Realm, KMP Observable View Model, and also a plugin for generating Swift packages from shared KMP code. First library we're going to talk about is Realm Kotlin. Just another quick show of hands. Anyone here using Realm? Okay, 4 or 5. As described in the documentation, it makes persisting, querying, and syncing data as simple as working with objects in your database. The first thing we need to do is create a Realm instance, which we'll use to interact with the database. We pass it the object types we're going to be working with, in this case just the one representing a bike network. And this is that bike network object, used, for example, for displaying the information shown on this screen on various platforms. Now, by subclassing Realm object like this, we're able to directly persist this object to the database. And here's an example of code to iterate over the list of networks we got from the back end and write them to the database, using realm.write to create a transaction, and then copy to Realm to actually persist the object as shown here. And a small example then of code then to read those network objects from the database, returning a flow which again we can use to drive our UI. Next up is KMP Observable View Model. This is the library that up to a few months ago was known as KMM View Model. It's now described as a library to use Android X Kotlin view models from SwiftUI. Key aspect of what it offers is ability to expose Kotlin state flows, for example, as Swift properties that can be directly observed in SwiftUI, as we'll see shortly. This is an example of one of the shared view models in the bike share project, in this case exposing the list of countries we're displaying. We're using our repository class to get the list of countries, doing some transformation of that information, and exposing then as a Kotlin flow. And this is how that's consumed in SwiftUI in the iOS client. We instantiate the view model we saw in the previous slide using the add-state view model property wrapper provided by the KMP Observable View Model library, which then allows that country list state flow from the view model to be observed directly here as a Swift property, which is very powerful. And this is the Compose equivalent. Here we observe the state flow as normal, using, for example, collector state, as shown here, though that should probably be collector state with lifecycle, I just realized. As with the SwiftUI client, any change to country list will cause the UI to be recomposed. Next up is a Gradle plugin that generates a Swift package from shared code, which can then be easily consumed in Xcode. Another quick show of hands, those people using KMP, how many people are using Swift packages? Exposing their, okay, very good. It's an interesting model in terms of how you how you package the KMP code and make it available to your iOS developers, so that in many cases maybe they don't know it's KMP code, which is sort of not a bad result sometimes. This is an example of the associated build config for the bike share project. Here we're targeting the iOS and macOS platforms. In this case, the output of that plugin is published to a separate GitHub repository, but that could also be done in the same repo. In this repo, by the way, we're including samples of SwiftUI code. You can use them to consume the Swift package, as we'll see next. And a small recording then showing how to add a Swift package to an iOS project in Xcode. We start with a new iOS project. We then copy the URL of the GitHub repository containing the package, and then use that to add a package in Xcode. Lastly, we copy the sample SwiftUI code from that repo README and paste it in, and we're ready to go. Wanted here to also show just how easy it is, in general, to consume a Swift package containing shared KMP code like this. And what's shown here is the same regardless of what that package or how that package is created. And we see here the super basic iOS app showing the list of bike networks. And by the way, another more recent and much more comprehensive approach you can use for creating such packages is Cambridge, which I definitely recommend folks taking a look at. It takes care of both producing the package and publishing it, and also provides capabilities for local development as well. It's an approach I've actually started to explore using in the Confetti project. Okay, the second last sample we're going to use today is Climate Trace. This displays per sector emission information for different countries. Again, we have an iOS and Android client, and also a Compose for desktop and WASM-based Compose for web ones as shown here. In this project, we're using the KMP Observable View Model library to share our view models. In this case, actually using Molecule to create our UI states. Okay, one last call for the audience participation. How many people using Molecule? Okay, Ed again. We're using Ktor to connect to the back end and Kstore to persist the data locally. And this sample is also using Compose UI code across the clients. And as here we'll be talking about Voyager, Molecule, window size class, Compose on iOS, and Jetpack navigation. So first up, Voyager. This is primarily a navigation library that works across a range of Compose multi-platform clients. It supports a wide range of functionality, including different navigation types, state restoration, transitions, lifecycle callbacks, backpress handling, and deep link support, along with integration with a number of other frameworks. It works on the basis of having our Compose code contained in these screen classes. This is an example from Climate Trace of the screen showing the list of countries. And we see then use of Voyager's navigator.push when an entry is selected in that country list, causing us to navigate to the country emission screen, passing in the country object. And this is an exit from that country emission screen. We can see here then use of Voyager's navigator.pop to navigate back to the previous screen. Next library we're using in the sample is Molecule. It's described simply as a way to build a state flow or flow using Compose. We're talking here about Compose runtime here rather than Compose UI. This is typically done as part of, say, a view model to create observable UI state, with that implementation then very strongly encouraging a unidirectional data flow type approach. So this is part of what we have then inside our view model in the Climate Trace sample. In this case being used to expose UI state for emission information for a particular country. Key thing here is this call to launch Molecule to create the state flow representing our view state. And it does this by using the country details presenter composable, which we'll show next. We also define the events, mutable shared flow, representing the events that the view model will handle. And this is part of the country details presenter composable. Here we have some composable state. Any changes will cause country details presenter to recompose. In the launch effect, we collect the events we mentioned in the previous slide and set certain state based on those. For example, the country or the year that the data is for. And here we react to that country or year state being changed to make a number of requests to our repository, the results of which then are used to create our UI state, which will be returned from the composable. So quite a different approach and requires different mindset, but definitely an interesting option, and one that I think maybe becomes a bit more applicable as the number of data sources we're using to create our UI state increases. Another Compose multi-platform library we're using in this KMP port is this KMP port from Chris Bain of Android's Material 3 window size class. This allows creating adaptive UIs based on a set of window size breakpoints that we can generally apply across our clients. In this example of different layouts, we dynamically show depending on the screen size, showing list and details in a column on the left, and then showing in a row as the window is resized. And we see this in action here as well. These particular layout configurations are, of course, just one example Another common approach is to switch between list detail and a list as the window gets smaller. Just a small aside, if people are using Compose Multi-Platform, if you're tracking the, pre-release of the 1.7 beta came out, I think, this morning or last night, this is actually provided, included as part of the offering. The third-party library is no longer needed, but the API is effectively the same in both cases. And this is a distilled version of some of the code used. The specific layouts aren't too important. Key thing here is how we're querying for the window size class in shared UI code and showing different layouts depending on what it's set to. And the UI will get recomposed then whenever a change causes the width or height of the window to cross a breakpoint. Next thing I want to show here, also from the Climate Trace project, is a small example of shared Compose UI code being consumed on iOS. We have, for example, this function exposed from our iOS main code in our KMP module. It uses Compose Multi-Platform's Compose UI View Controller, which in turn includes the country list view composable function, which is in shared common code. And then on iOS, we take advantage of the ability to include a view controller in Swift UI code. Here we define such a view controller, this country list view shared struct. And that in turn invokes the shared Compose country list view controller we showed in the previous slide. Here we also pass a callback that's invoked when the country is selected in that list. And I'm using this approach in several of the samples. Lastly, for this project, Jetpack navigation. We're using a version of the library that was included in a recent Compose Multi-Platform beta and expanded on in subsequent versions. This shows some changes that were added to Climate Trace to try it out, available in the branch if people are interested in taking a look. Same code as we'd use, for example, in an Android app, but this time it's shared Kotlin multi-platform code. And another aside here, by the way, Android developers probably tracked that you can use strongly typed approach with the navigation library in Android, and that's now available in Compose Multi-Platform as well. In this example, still, we define a number of routes which we can navigate to, for example, the list of countries and details for a particular country. So this is a nice capability to have now, and one more thing that makes migration from existing Android apps much easier. We'll talk more about various other Jetpack libraries that now support KMP in the next section. Okay, we're nearly there. Next up is Fantasy Premier League, the last of the KMP samples we're covering today. The project displays information for a competition for the main football league in England. These are screenshots, again, for the Android and iOS clients. And this is the Compose for desktop client. So in this project, we're retrieving the data from the backend, again using Ktor, storing locally using Jetpack Room, thanks to its new KMP support. We're also using shared view models, but in this case, we're using the recently announced version of the Jetpack view model library that now supports KMP. And also using shared Compose UI code, in this case for the player details screen we'll see shortly. In this section, we're going to talk a little about the use of the aforementioned Jetpack view model, Jetpack Room, Jetpack Data Store, Sky, and Qualiplot libraries. So as you probably gathered, this project has sort of become my designated Jetpack KMP sample. As you can see here, we've rapidly got to a point where several key Jetpack libraries are now available to be used in shared Kotlin multi-platform code. And I think this is something that has really excited the dev community. Now, as I said before, whether these libraries are the best solution for a particular functionality they provide is a different story, given the options we now have in the KMP world. But key thing is that having them provides, as I said before, a very nice migration path for existing Android apps. One library actually that I'd forgotten to include in that tweet to the previous slide was Jetpack Paging, which actually had its first stable release recently as well. And this is used, by the way, in the Morty KMP samples I have. So first of these Jetpack libraries is view model, again, one that will be very familiar to most Android devs. Used as part of a general MVVM pattern, its role is primarily as a holder of observable UI state and as a conduit of actions that would typically affect that state. The Jetpack version has had some additional responsibilities in the Android world around the caching of state through configuration changes and as part of navigation graph, etc. With the KMP support now, and importantly also that of the lifecycle library, this has now been generalized to work on other platforms as well. So this is a small example from the project. It looks like a standard Android view model that many of us have used in Android apps before. Difference here that this is defined in shared common Kotlin multi-platform code. We'll talk shortly, by the way, about how we're using the Sky library to access that state flow in Swift UI code. Next library we're going to talk about is Jetpack Room. It provides, as described here, an abstraction layer over SQLite. And this is one of the entities from the project that we're going to persist, in this case for information about a particular player. Just a standard Kotlin data class marked with @entity annotation. We then have this abstract class in common code representing the database, and that's also used to access our data access object. We're also providing here the list of entities we're working with. A SQLite database table would be created for each of those. And as we've done elsewhere, we use KMP's expect actual mechanism to create platform-specific implementation of that database class. And this is the data access object we referred to in the previous slide. Here we define various database queries we'll be making, showing just the ones related to a player here. We have methods for inserting the list of players, returning the players in the DB as a Kotlin flow, and also retrieving a particular player by ID. And it's this data class, or this class rather, that we'll be using in our repository. And showing excerpt from that repository class here, we inject the app database instance using coin, and then use it to get the data access object, which we use then to write info to the database. And also expose what's in the player table in the database as a flow, along with the method to get the particular player by ID. So next up is Jetpack Data Store. Similar to the view model, it's another Jetpack library that now supports KMP. It's been available in pre-release versions for a while, but went stable again relatively recently. It supports storing key value information, as well as typed objects using protocol buffers. This sample had in fact been using the multi-platform settings library that we saw earlier, but it was recently migrated to use data store directly. And this example is being used to store the particular fantasy leagues a user is part of. The data store object is injected into the constructor, again by coin, with implementation again being created in platform-specific modules. We have methods to update the list of leagues, and also to return the list as a flow, which can be observed. And this is what we have in the platform module for Android. Specific details are not too important, but just to show again how, as we've seen a few times, KMP's expect actual mechanism in conjunction with coin allow us to easily plug in platform-specific code like this. And similarly then for iOS, again, we won't focus too much on the specific details of how that data store method is implemented. Next library we're going to talk about from this project is Sky from TouchLab. Sky stands for Swift Kotlin Interop Enhancer, and supports a range of functionality as mentioned here. We'll show how we're using some of these features in this project, specifically the coroutines flow and sealed classes support. First up, invoking Kotlin suspend function from Swift. We have this getEventStatus suspend function in shared Kotlin code, and we're able to use Swift's await to invoke it then in our iOS client, thanks to Sky. And likewise for flows. We have that player list UI state flow in our view model, which we can then use Swift's for-await to observe that in the iOS client, in a Swift UI task view modifier in this case. That Swift for-await, as mentioned before, is analogous to Kotlin's collect. And as with KMP native coroutines, when the Swift UI screen that's used in is no longer shown, then this is cancelled and that cancellation is propagated to the Kotlin flow. Another area where there's a disconnect between Kotlin and Swift is sealed classes, and this is something Sky also addresses. We have this player list UI state sealed class that's being emitted from our view model, as we saw before. Sky then provides a way to exhaustively switch over the sealed class hierarchy by generating a Swift enum that wraps the Kotlin sealed class. And we see an example here in Xcode where it reports this switch must be exhaustive error then if any of the cases are missing. I mentioned we were sharing Compose UI code for the player details screen across the clients. That screen shows a graph, and we're using the Qualiplot CMP library to show that. It supports a wide range of different chart types, but we're using it in this project for a standard bar chart, as we'll see next. And this is the somewhat condensed version of the code then to show that chart. Key thing again is that this is shared Compose UI multi-platform code that we use for all the clients. For example, in the iOS client shown here. Okay, so that was a whirlwind tour of many of the Kotlin and Compose libraries used in various KMP samples I'm involved in. Shown here again the ones we covered today, broken down by function. We have libraries, for example, for persistence, remote API requests, dependency injection, view model component sharing, navigation, Swift Kotlin interop, packaging, and some Compose UI multi-platform libraries as well. Hopefully you got at least a flavor of the capabilities these libraries provide and how they can be used. As mentioned, I'll make the slides available, so they hopefully act as somewhat of a reference from the material we covered here today. Thank you. Not sure if any questions.
Hi, thanks very much for the talk. So we're also trying to get into some Kotlin multi-platform work, and I think some of these interop libraries might be very useful, because having these Objective-C annotations is like a big red flag for a lot of our iOS team. Yeah. Is there any good places to start with getting, I don't know, it's probably very difficult, but yeah, if you have any ideas on good places to start with small, I don't know, small bite-sized chunks to convince, that'd be great.
Yeah, I mean, I guess the samples, hopefully, some of those samples might be a good example. The other thing, by the way, just as I meant to mention as well, it's quite a very early stages right now, is Swift export. There's work going on by JetBrains to expose directly, have direct Swift Kotlin interop. Having said that, it's just a different set of disconnects in many cases, and you still need libraries like this, I think. Yeah, so Sky, TouchLab themselves are a great resource, obviously. They've been a lot more active in recent times in publishing blog articles about some of their own libraries, obviously, and things, and they have samples as well. But I'm using Sky more and more in my own samples. Sky is a relatively recent addition to the ecosystem. KMP native coroutines has been around a lot longer, and one I would traditionally use. Sky is a little bit more broad in what it provides, as well as sort of the coroutine support. It supports things like I mentioned with the exhaustive, with the switches and so forth, and also uses the KSP compiler to give a sort of a more seamless interaction. In KMP native coroutines, you need to wrap the calls in. So certainly from that perspective, in terms of persuading iOS developers, I think the Sky actually, the API surface looks a lot cleaner. It looks like you're just interacting. I kind of touched on the Swift package. It depends on the team organization, but at least in some cases, creating the KMP code as a Swift package, which then becomes just another Swift package of many others that an iOS developer is pulling into Xcode. That makes it somewhat a little bit easier to consume as well. But yeah, hopefully some of the samples there might be useful, perhaps.
Yeah, definitely. Well, check it out. Thank you very much.
No worries.
Hi, thank you for the talk. I have a question. I'm trying to build a Kotlin multi-platform library for Android, iOS, and TypeScript. And I don't know if I missed something, but I have a problem with array and lists. So lists is compatible with Swift UI, with Swift, but not compatible with TypeScript. So I have to use array, which is really weird to use then in Swift. Did I miss something which can enhance that?
I'm sorry, it's not something I've used. I guess, in the early days we would have sort of had Kotlin.js and the Kotlin.js wrappers and the React wrappers and so forth. And I guess more recently we have the ecosystem has moved, I suppose, at least for Compose for Web, towards WASM-based support. So I haven't seen much discussion, unfortunately, in that area. Sorry.
No problem, thank you.
Hello, once again, thank you. A question, have you ever experimented with Cobweb?
What, sorry, say it again?
Cobweb, it's like Compose for Web, but it's not WASM.
Oh yeah, I've come across that before, but it's one of the things I meant to look at, but I never got a chance, no. So, yeah, sorry.
Okay.
Not something
Just wanted to hear your thoughts about it, but thank you.
So, yeah, just briefly on the, again, if people aren't familiar with, WASM is a relatively new addition to the sort of web ecosystem. It's quite new. A lot of the browsers are only starting to support it, but it's something that JetBrains have really sort of focused on for sort of Compose for Web, what they call the Compose for Web. As part of Compose for Multi-Platform, you have Compose for Desktop, Compose for iOS, and Compose for Web. And WASM is sort of where they're focusing, and it's a very technical preview, got its first WASM support recently, and can now run Compose for Web clients. So the support is getting more broad, but it's still a little way out before it's, I think, widely usable, I think. Okay. I think that's it. Thank you. Oh, sorry, one more here.
Hi.
Hi.
How would you implement worker manager tasks, for example, running a job in Kotlin multi-platform when, for example, internet appears?
So it's an interesting area, and it's one I think where most people are. So again, a critical aspect of KMP in general, and also Compose multi-platform, is the ability to use platform-specific capabilities as and when you need them. Working on a project right now, for example, is using Compose multi-platform, but we're using SwiftUI for a component within that, for example. But speaking to your specific question, then that's another one where people are typically using platform-specific. The work manager on Android and the background refresh, I think, is it, on iOS. So I don't think there's a general. There's going to be certain areas where there are platform touch points that. I guess in some cases, I guess like any of these things, I guess there are more libraries available. At least try to abstract you from those and wrap them around. But at least there's the capability to dip in and use the platform capabilities. In terms of that, I think as you kind of alluded to there, I guess with the network, I guess probably still need some hooks into, if you have shared networking code, for example, you probably need some communication and some hooks back and forth between your sort of platform-specific code and your shared code.
Okay, thanks.
I think that's it. Thank you very much.
Hello. Good evening, everyone. I know it's the last talk of the day and parties on everyone's mind. So I'll try to keep this talk a brief. So what are we waiting for? Let's dive right in. We all rely on passwords for almost everything, from banking to emails. Almost we can think a lot of options here. But what would happen, let's say, if you are in the middle of an urgent task and you forget your password? Let's think more worse scenarios. What if your password gets compromised in a cyber breach? I know it's frustrating. So, in today's digital era, it's time to rethink security. Why not enter passkeys, a secure, user-friendly alternative to passwords, which can actually save us from a lot of nightmare scenarios? So, in today's talk, we'll explore what passkeys are, how they work, and why they are a game changer for security and user experience. Plus, I'll show you how you can start integrating passkeys in your Android apps to prepare for passwordless future. So brace yourself for a live demo, and fingers crossed that net works. Before moving ahead, let me introduce myself. I'm Ayushi Gupta, a GDE WTM ambassador. So if you have any questions around this program, I'm going to be around. And currently, I'm working as an Android engineer at Zalando, based out of Berlin. More details could be found at my website, and feel free to connect with me on Twitter. Introducing my partner in crime, who is unfortunately not here with us today because of visa constraints, Gaurav Bansal, who is a co-founder at GeoTestRack, based out of Mumbai. He is an XR expert and AI/ML enthusiast. Feel free to connect with him on Twitter. Login. Login process is a critical component of the majority of the apps. If we check industry insights, around 60 to 80% of mobile applications include some form of login or any authentication mechanism. Let's take a closer look at the various login methods currently available. I know the first one, the traditional classy username password combination, which is simple, quite familiar, but comes with significant vulnerabilities. It's highly susceptible to phishing, password fatigue, and brute force attacks, making it quite a less secure in today's digital landscape. Many users turn to password managers to store and create a strong password. But the point is, how much? The number of users who actually use password managers are pretty low, leaving high security gaps. Then came email and password combination, trying to make the email recovery quite easier. But again, they are susceptible to email phishing and password breaches. These both methods are quite familiar in the industry, but they highlight the need for more robust and secure alternatives. So, to enhance the security methods, developers came up with new options, such as two-factor authentication, which is like you're adding a second layer of security by adding a one-time code, or which could be through SMS, or let's say email, or an authenticator app. No doubt, it significantly boosts security. But again, it's adding an extra step for your users, which could be inconvenient and may even add like a cost to your pockets. Then came MFA, multi-factor authentication, which goes a step further by combining two or more authentication methods, such as password, maybe your facial recognition or fingerprint, plus SMS code. Highly secure, no doubt, but again, more complex, making the login process quite cumbersome for users. So, as user convenience became a focus, new login methods were emerged, such as social login, where you are using to sign in with your social media accounts, reducing the friction of login, as well as remembering the passwords. Again, it involves sharing the data with third parties, and may even come up with additional cost. Biometric authentication, Very fast, very secure. But you need a compatible hardware for it. Then came SSO, single sign-on, where you're using a single login across various services. But what if the SSO provider gets compromised? All the connected services are at risk. All the traditional authentication methods, including passwords and SMS OTP, they are relying on knowledge-based system, which are not only a hassle to remember, but also susceptible to phishing, harvesting, and a lot of replay attacks. If we see the statistic, which actually highlight the extent of these issues, passwords are responsible for more than 80% of data breaches. A typical user kind of manages over 90 online accounts. Let's say you have to reset a password, then each password reset costs an average of $70 in a help desk labor. Not only that, up to 51% of passwords are reused across different sites. All of these figures underscore the need for more secure and user-friendly authentication system. So, why not, let's say, goodbye to passwords? And it's time to say hello to making our digital lives more simpler and more secure with passkeys. I know most of you would be thinking, what is a passkey? Let's try to seek answer on this. Passkeys are passwordless authentication methods, which is built on FIDO, Fast Identity Online Standards. They're actually designed to overcome the weaknesses of traditional passwords. A passkey is a digital credential which is linked to a user account and a specific website or an application, which is like you're enabling secure phishing-resistant authentication without the need for passwords or any extra authentication. You're actually replacing outdated methods. It's like embodying FIDO's vision for passwordless future. I know you would be thinking, how does it work? Let's try to find out. There are two phases of this journey that we're going to talk about. First phase is passkey creation. Obviously, this is how the journey of login starts on a general app. You click on a register button. What happens post that? Then, on the behalf of user, the client, which could be a native app or a web app running across the browser, it takes the input and start calling to the backend to get the challenge. What is a challenge? A challenge is a random generated server string which contains enough entropy, making it guessing it like quite infeasible. And the ideal is that it should be at least 16 bytes long. That's a must. Now, the server has created the challenge. It has given back to the client. Now, client calls WebAuthn API to create with that particular challenge. It's like it's handling over the challenge, which results in a key pair generation, which is private key and a public key. Private key is the passkey. And we are using this private key to sign the challenge that we have received from the server. And it's going to be, like this particular private key is going to be stored on your device secret, I would say secure hardware, where this private key going to be stored. Now what happens? The private key with which you sign the challenge, it's stored on the user's device. The matching public key, a credential ID, as well as the signed challenge, which we have signed with the private key, is all collected and given back to the server. But before doing that, you might have to enter your biometric or PIN. It's like you have to give a consent that, hey, yes, you can share out the public key of my device. Now, to finalize all the process of passkey registration, the client has already sent the public key. We are not sending out the private key. We are only sending out the public key. Public key plus credential and some username plus some metadata of the user to the server. Now, what does server does? It again re-verifies the signed challenge with the public key. It's like it's making sure that yes, the user was genuinely in possession of the device, and it saves the username and public key matching that yes, this username, this public key, let me store it in my data. And that's it. It's all done. Now what would happen the next time when you try to authenticate? First, the client would call again to server to get a challenge. Challenge the same random string. As soon as the server gives out the random string, the client will call WebAuthn API to get challenge, which results in prompting the user for verification. Now, that verification could be biometric or a PIN. It's like you're giving a consent key, OK, you can open the secure hardware and take out the private key. And again, the private key would be signed with this particular challenge. The signed challenge, as well as the username and the credential of the used passkey, are returned by the function. Now, to finalize the entire process of authentication, the client sends out the signed challenge, the username, and the credential ID back to the server. The server now checks if the username and credential ID are known, like generally you are the previous user who came to me. If so, it will pick up the public key to check the validity of the signed challenge. If the signed challenge can be successfully verified with the public key, the server can safely assume that the user was in possession of the device. And it will create a session or hand out an authorization token. That's it. In this entire journey, you were never asked to enter any of your password. You are just using your fingerprint or the PIN, I think, which you all know because you're using your devices. We are not handing out the private key. It's already in your secure device. It's not going out. And only the public key of the user is sent out to the server. Let's look into where the passkeys are in support. So in Android apps, passkeys are supported through Credential Manager. Credential Manager support passkeys, passwords, and a lot of identity federations. Passkeys are supported on devices that run on Android 9 or higher. Not only that, Chrome or Android OS 9 or later support passkeys. So passkeys which are generated in Chrome are actually stored in Google Password Manager. So now, these passkeys are going to be available on all other Android devices which have Google Password Manager, and you are logged in with the same Google account. So let's say you logged in on Chrome on a website, and you have a passkey created. Now you're using your phone, same website, and it won't ask for your password. You can easily log in with the passkey which you have stored already. Not only that, Windows, Chrome on Windows store passkeys in Windows Hello, which doesn't synchronize them to other devices, like as of now, like October 2023. But when user tries to sign into the website for the first time on Chrome or Windows, you can actually scan a QR. Let's say you have a phone which has Google Password Manager, so you can scan a QR and create the passkey of the same website on your phone. That's it. Chrome on Mac OS, I think 13.5, and later can use iCloud Keychain to store passkeys. So passkeys in iCloud Keychain are synchronized across devices on the same Apple ID. And that's it. It would be, you can magically use all the passkeys across all your Apple devices. Let's talk about Linux. Chrome on Linux doesn't support passkeys with a built-in platform authenticator. But Linux users can use passkeys from another device, like we talked, such as an Android device or an iPhone, by scanning a QR code. Passkeys are not something which are in an experimental stage as of now. They have been tried, tested, and already been in use by major of the companies, like Google, PayPal, DocuSign, maybe Mercari. So what's stopping us? Why not we start integrating it in our apps? But there are few integration requirements that we have to look into. First is, obviously, you would need a backend which stores public key and user metadata, and so that each passkey information knows like the server knows which passkey it's interacting with. Then comes Credential Manager API. API used for retrieving and storing users' passkey with credential providers available on the device. App, obviously you would need a front end, which will be communicating with the Credential Manager API and actually sends a fetch request to the backend. Lastly, but important enough, is the credential provider. The credential provider on the user's device, this provider actually creates and stores user's passkey. This could be on the same device, for example, Google Password Manager, and from Android 14, if you are using Android 14, some third-party credential provider could also be used. So these are the major 4 things that we would be requiring. I guess it's a time. I hope everything works. OK. I guess just a very simple UI. I'm going to start with the basic flow, which is the registration flow. I'm going to enter my name. Now you would ask why you need an email ID. So I'm using email right now as a form of validator. I want to make sure that this user is a genuine user. So let's say, should we use the temp email, or I guess let me use my personal email. OK, as always, the internet thinks. I think this is already registered. Let me try. I'm just using hello@gmail.com. OK, so right now, sorry guys, I didn't look at the screen. OK, so I have entered an email. I'm using a hard-coded OTP as of now. So you can make sure that your server talks to the backend and the email OTPs are generated. So right now, I've hard-coded it just for the demo purpose. And let's see what happened. OK, so right now, what we are seeing is the register passkey function. Should I make it a bit more bigger? OK, let me try it if this, sorry. OK, it's not working, I guess. So let me tell you what's actually happening. We were talking about the challenge the whole time, which is a random generated server string. So that's where it happens. Passkeys.convert and get a new challenge. So your server is creating a random string. And we give out some user metadata information, which is like relying party information, user ID. I think we could see the response, I guess. So yeah. It's some challenge, which is a random generated string. You could see it on the screen. Then RPID, which is the relying party information. And the user information, which is like this we were talking about, plus some credentials that would be handed out. I guess I have to do the entire flow again because I clicked on cancel. OK, now as soon as the server gives out this response, let's try to see on the Android side what happens. We were talking about Credential Manager API. So first thing is we create a request to get the public key of this particular credential. So an application, like this is the base request class for registering a credential. And if you see it, it's coming from Android X credentials library. It's already been created for you. Now, as soon as the request is created, hold on for a moment. OK. So you can see there is a launch UI which is coming in, right? From where this UI is coming in. So Credential Manager is actually creating the launch UI for you. It will create a UI. It will also collect consent and any other metadata which is needed from the user to register a new user credential. So you could see it's asking me to verify my identity. So let me enter that. I know. Let's add one more. And that's it. Everything is successfully created, and you enter on the login page. That's it. You were never asked to enter any form of password. Do you remember the email I entered? Sorry, is someone attentive? What was the email? OK, let's see. Hello? 12? I guess @gmail.com? OK. So when I'm trying to log in with the same email, it's again asking me to use the stored passkey. I'm not entering any of the passwords. So what would happen, like what's happening at the background? So here, like the same thing that we have seen, we ask for a challenge from the server gives out a challenge, and again, this UI is coming from Credential Manager API. And that's it. I would give the option that yes, sign in. It will again has to verify that yes, I'm the one who is doing it, because it will be taking out the private key, which is stored in a secure vault, signing the challenge, and giving back the public key for the again flow. So that's it. You have logged in into the app. In this entire journey, you could see it's highly secure. You are using your biometric or your PIN, and you are nowhere using passwords. There are few privacy considerations that come in with passkeys. Passkeys have been designed with user privacy in mind. With passkeys, the user's biometric information is never revealed to the website or the app. And biometric material, again, never leaves the user's personal device. On the other hand, passkeys on their own don't allow tracking of users or devices between sites. So the same passkey is never used with more than one site. Passkey protocols are carefully designed so that no information is shared with sites which can be used as a tracking vector. Passkey managers protect passkeys from unauthorized access and use. For example, let's talk about Google Password Manager. It actually encrypts passkeys secrets end-to-end. Only the user can access and use them. And even though they are backed up to the Google servers, even Google can't use them to impersonate users, so making it highly secure and private. Let's look into the security considerations as well. Passkeys use public key cryptography. Public key cryptography reduces the threat from potential data breaches. So when a user creates a passkey with a site or an application, this generates a public-private key pair on the user's device. Only the public key, like we have seen, is stored on your backend. But this alone is useless for an attacker. An attacker can't derive the user's private key from the data stored on the server, which is actually required to complete the authentication. Like you have seen, without me giving the fingerprint or the consent, the authentication journey was not completed. And as passkeys are bound to a website or app's identity, they are safe from phishing attacks. The browser and the operating system actually ensure that the passkey can only be used with the website or app actually which created them. So it actually frees you from being responsible for signing in into a genuine website or app. So it's all highly safe and secure. But there comes few best practices that you have to look into when you are developing passkeys. First is utilize Android's native APIs. For example, biometric prompt to ensure seamless passkey integration. Not only that, make sure you implement a fallback authentication. For example, biometric or PIN for users who may not have passkeys enabled. Then comes educating our users, which is we being developers, we have to be responsible for that. So clearly communicate the benefits and the process of using passkeys, actually to encourage adoption. Not only that, ensure that cryptographic keys are stored securely using Android's trusted execution environment, or maybe similar secure storage option. Then comes user experience optimization. It's like design the UI UX to tell why is this important. So let's say when you're building for your own existing login system, you can have the existing sign-in journey and then give an option to the user to enable passkey for your apps, so that user knows that, okay, this is an extra step could be useful for me and I don't have to give password again. And last, but again important, keep the app updated to support the latest security protocols and passkey standards. So let's have a recap. We have seen in these slides the innovative concept of passkeys, a secure and user-friendly alternative to traditional passwords. We have actually seen how public key cryptography is working in brief, effectively eliminating the need for passwords and reducing the risk of cyber breaches. We actually delved into the benefits that are coming with passkeys, such as enhanced security, improved user experience, and streamlined authentication process. I hope the integration process just give you a hope that you can also start adding passkeys into your Android apps. It's like paving the way for passwordless future, offering a more secure, more seamless experience for the user. Let me share out a few references with you so that you can start integrating passkeys into your Android apps. So all the demo is up on the GitHub. You can try, test it out, and let us know if there is something missing. OK. And lastly, thank you, everyone, for being the patient audience. I guess I say it right. Obrigado. Happy coding, guys. I guess, should I keep the party waiting? Or if you have any questions, you can stay here and rest everybody can start the party.